Welcome back, and in this video of my DNS series I want to talk about DNSSEC. Now this is the first video of a set which will cover DNSSEC, which provides us with a lot of additional functionality and so requires a few dedicated videos. Now to get the most from this video, it's important that you've watched my previous videos on DNS as well as on hashing and digital signing. If you haven't, all of the videos that you need are linked in the description and you should watch those first or have equivalent knowledge. DNSSEC is a secure add-on for DNS. It provides additional functionality. In this video, I want to set the scene by talking about why we need DNSSEC. So let's jump in and get started. Now I promise this bit will be super quick, but I do need to use some bullet points. I hate bullet points as much as anyone, but sometimes they're just the quickest way to present information. So let's go, and please stick with me through this first set of important points. Now DNSSEC provides two main improvements over DNS. First, data origin authentication, and this allows you to verify that the data that you receive is from the zone that you think it is. Are the records returned to you from Netflix.com from the real Netflix.com? If you're looking at cached results, are they really from that original zone? Second, DNSSEC provides data integrity protection. So has the data that you receive been modified in any way since it was created by the administrator of the zone? So if you have Netflix.com data, is that the same unchanged Netflix.com data which the administrator of the Netflix.com zone created? Now it does both of these things by establishing a chain of trust between the DNS root and DNS records. But it does this in a cryptographically verifiable way. Where DNS has some major security holes, DNSSEC uses public key cryptography to secure itself in a similar way to how HTTPS and certificates secure the HTTP protocol. It means that at each stage you can trust if a child zone has the trust of a parent zone, and you can verify that the data contained within that zone hasn't been compromised. Now another really critical part of DNSSEC to understand before we touch upon why it's needed is the fact that it's additive. It adds to DNS, it doesn't replace it. It's more accurate to think of any queries that you perform as either using DNS on its own or DNS plus DNSSEC. Conceptually, imagine DNS at the bottom with DNSSEC layered on top. Now in a situation where no DNS exploits have taken place, it means that the results will be largely the same between DNS and DNSSEC. Let's say that we have two devices. The one on the left is DNS only and the one on the right is DNSSEC capable. When querying the same DNS name servers, the DNS only device will only receive DNS results. It won't be exposed to DNSSEC functionality, and this is critical to understand because this is how DNSSEC achieves backward compatibility. A DNSSEC capable device though, this can do more than just normal DNS, so it still makes queries and gets back DNS results, but it also gets back DNSSEC results, and it can use these DNSSEC results to validate the DNS results. Assuming no bad actors have corrupted DNS in any way, then this will go unnoticed since the results are the same. But consider a scenario where we have changed DNS data in some way. So again, we have two devices. The device on the left is DNSSEC capable and the one on the right is standard DNS. So the DNS only device performs a query and it thinks it's getting back the genuine website result, only it isn't. In an exploited environment, it will be unaware that the result it gets to queries are bad, and so the website it browses to might not actually be the one that it expects. With DNSSEC, the initial query will occur in the same way, and even though it's corrupt and will look valid, what follows is that DNSSEC will verify the result, and because public-private key cryptography is used together with a chain of trust architecture, DNSSEC will be able to identify that records have changed or they come from an origin which isn't the one that we're querying. Now, it's important to understand that DNSSEC doesn't correct anything. It only allows you to validate if something is genuinely from a certain source or not, and if it's been altered or not. It doesn't show you what the result should be, but in most cases it's enough to know the integrity of something is valid or in doubt. Now, it might help you to understand one of the common risks posed by normal DNS if we step through it visually. So let's do that. Consider this architecture. We have Bob on the left who is about to perform a query for the IP address of catagram.io using this resolver server. But we also have a bad actor, Evil Bob, at the bottom, and in advance to perform this exploit he performs a query for catagram.io. This begins the process of walking the tree. But while that's happening, during this process where the resolver is walking the tree to get the true result, Evil Bob responds with a fake response. It pretends to be the real server. So even while the real process is continuing, Evil Bob enters false information into the resolver server in the middle, and this result is now cached, and the cache has been poisoned with bad data. This means that when Bob queries for some catagram.io records, he's going to get the poisoned result. This result is going to be returned to Bob, and the effect of this is that Bob is going to be directed at something that he thinks is catagram.io but isn't. Now, this is just one way that DNS can be disrupted. It's oversimplified and there are some protections against it, but it illustrates how DNS isn't secure. It was built during a time period where the internet was viewed as largely friendly, rather than the adversarial zone which it now is from a security perspective. Now at this point I just want to switch across to my command prompt and show you how a normal DNS query differs from a DNSSEC query. So let's go ahead and do that. Okay, so we've moved across to my terminal and I'm just going to go ahead and use the dig utility, which is a DNS utility, and I'm going to perform a normal DNS query. So this is the command dig space www.ican.org, and if I run this query, this is the result that we receive. It's this answer section which I want to focus on. Now, just to reiterate, this is the query that I've performed for this DNS name. So in the answer section, we have a result for www.ican.org, and the result is that it's a CNAME, and this CNAME points at another DNS record, in this particular case, www.vip.ican.org. So directly below, we can see this DNS record, so www.vip.ican.org. This time it's an A record, and A records point at IP version 4 addresses. And this is the IP version 4 address which corresponds to this DNS name, and this DNS name maps back to our original query. Now, because this is normal DNS, we have no method of validating the integrity of this data. You can see here that I'm querying this DNS server, so 8.8.8.8, and this is not a DNS server that's affiliated with the ICANN organization, so this result is not authoritative. It's possible that this data is not valid, either by accident or because it's been deliberately manipulated. Now, DNSSEC helps us to fix this risk, and let me show you how. I'm going to start by clearing my screen, and then I'm going to run the same query but using DNSSEC, and I can do that using this command, adding this additional option on the end of plus DNSSEC. When I run this, I receive both DNS and DNSSEC results. So www.ican.org, it's a CNAME and it points at this DNS record. Slightly below it, we can see the record that it points at. This is an A record, and just as with the previous query results, it points at this IP version 4 address. Now what you'll notice is for each of these normal DNS results, we also have this RRSIG, and this is a DNSSEC resource type. This is basically a digital signature of the record that it corresponds to. And I'll show you in the next video how this digital signature can be used to validate the normal DNS data that's stored within this zone. So we can query for normal DNS results and then validate the integrity of those results using DNSSEC. Now in this part of this lesson, I just wanted to demonstrate exactly how a DNSSEC query result differs from a normal DNS result. In the next video, I'm going to expand on this and step you through exactly how these signatures work within a DNS zone. At this point, let's move back to the visual. Okay, so what I just demonstrated is a way to avoid this kind of attack, because even if a cache was poisoned, a DNSSEC capable resolver would be able to identify the poisoned data, and that alone is a huge improvement over standard DNS. So at this point, I hope you have a good idea of some of the ways which DNSSEC improves normal DNS. That's it for this video. In the next one, we're going to explore exactly how DNSSEC works in detail. Now, it's a lot to get through, so I wanted to make sure that each different area of DNSSEC functionality has its own dedicated video. At this point though, thanks for watching. Go ahead and complete this video, and when you're ready, I look forward to you joining me in the next.